Okay, in this video we're going to take a look at using the Johns Hopkins Truss calculator. So you can find that by searching Hopkins. Hopkins is well-known engineering school, well-known medical school. Hopkins Truss simulator. And that's the first thing that shows up on the list, and you click on this and you're ready to go with a truss simulation. Okay, so we're going to take a look at the truss that we did in the method of joints example number 1. And the first thing I want to do here is make the window size a little bit bigger. So I'm going to do 1200 pixels, and that just gives us a little more room to look at putting the truss on a grid. All right, I'm also going to change the grid size to 0.05 in the X direction, and that's because one of the dimensions was 0.75, and that lets me get the 5 part of the 0.75. Okay, so hit enter on that, and I get a little bit finer grid in the X direction. Okay, this is pretty intuitive on how to use. There's some options that you can look at down here to make your answers look a little different. We'll talk about that once we get something up and running, but it's pretty easy to get this working. So notice as I move my mouse around, look right in here, you see the coordinate system change. Okay, and you could look at pre-built trusses, or you can build your own. That's what we're going to do here. Okay, so to build a truss, you add the joints, they call them nodes here. Okay, and then once you have it all added, you can hit solve and it will do a simulation. It gives you a key that C is in compression and T is in tension. All right, so you'll see how this all works out. All right, so the first thing I want to do is add some nodes, and I'm going to put, remember we had this previous problem that we worked. It was a truss, and it had joints labeled A, B, and C. All right, it had B here at the origin. We call it, 0 is the same as joint B. And then 1.4 meters up, so I'm noticing my mouse location, 1.4 meters. Boom, I hit that, and I've got the second location. And then I also wanted to show you how you can do text entry. So I'm just going to randomly place this one over, node 2 is just randomly placed. It's not in the right spot. What I want for the right spot is the X coordinate to be 0.75 and the Y coordinate to be, actually I just happened to hit it right at 1. All right, so if you look at the dimensions of that drawing, the coordinate point for joint C would be X value 0.75 and the Y value equal to 1. All right, so at that point we have this set up. All right, so you can check it, 0, 0, 0, 1.4, 0.751. We've got the node set up. Next, this is pretty intuitive. You click on the member button here and then just connect the joint, connect the members between the joints. All right, then I have to add support for the truss. Okay, and what I remember from the problem is the vertical roller. Remember the little wheel was pointed to in the vertical direction for this problem. That goes here. And it was a pinned support at joint A, which we have labeled here node 1. Okay, so I've got the supports, and now I just add a force. The next thing we do is we add a force, and we need to add the force in this case at node 2, which corresponded to our joint C from example 1. So I just click on this for a certain direction here, and you notice it put minus 50, but really we wanted minus 2.8. And when you do that, it makes this really short because there's a force scaling that shows up that scales the forces according to this grid. So if I make this a 1, it wouldn't scale it at all, and I get a pretty long line. If I count that, this starts at 1 and ends at minus 1.8, so the total length is 2.8, which is what we're expecting, and the minus sign means it's pointing down. Okay, that looks a little weird, so you can actually scale this to where the diagram looks a little better. So I'm going to put a 10 there. And so you count the number of grids, that's 2.8 grids, you multiply by 10. So, well, you get the idea. It's ends up being a total length of 2.8. Don't worry about that detail. It's just making the pictures look better. All right. So I have a force scale here of 2.8. Right. Shows up right here in the y direction. I've got the supports. I'm ready to do the analysis. Okay. So I hit solve, and it gives me the answers. Okay. So we already had calculated this by hand, so we already know. This showing that this member is in 1.7 kilonewtons of tension, right? Remember, blue is tension. 2 kilonewtons for force AB. Again, that's in tension because it's blue, and then this is in compression because it's red. Okay, so one of the things I can do is play around with different forces, and I can increase this to 3 and see what happens. All right, if I move this, I'm sorry, put a 3 in there, that moved it up, and it changed the forces on the members, right? If I move the force and I pull up on it, okay, this member now goes into tension and these two into compression. So what I meant to do is change that to -3, point it down, and you change the actual values of the forces within the members. Okay, so this is good for simulating trusses, and this is what I'm going to want you to do when you build your bridge project. Okay, so you're going to put your truss in on the grid, and you can analyze where the forces are and get an idea of what kind of load your bridge will be able to support.